From now, I would like to present the topic of port connectivity in theory and practice with particular reference to Korea. When we talked about maritime connectivity of port, we need to mention the Liner Shipping Connectivity Index developed by UNCTAD. You can see the statistics by country can be retrieved from UNCTAD websites. However, I would like to explain in more details how the Liner Shipping Connectivity Index was developed and what elements were considered to build it up. The Liner Shipping Connectivity Index, shortly called LSCI, aims at capturing the level of integration into the existing liner shipping network by measuring liner shipping connectivity. The index is calculated based on 6 major components. Scheduled ships called concern the number of ships that are calling on a weekly basis. These calls can either involve imports, export, or transshipment activities. Deployed capacity is the total capacity of these services enables to link port calls with the related physical capacity. The higher the capacity, the greater the potential to trade on global markets. Next component is the number of shipping companies and liner services, which means how many shipping companies are servicing the country or the port, as well as how many scheduled services they are using to provide this coverage. Average and vessel size is a proxy to the available economies of scales, since they convey lower shipping cost per TEU. Final components is directly connected ports. The number of ports that are directly connected to the reference port. This figure shows the world map. The yellow dots represent the ports Liner Shipping Connectivity Index. The bigger dot is the more connected that port is. As you can see, the most connected ports are located in Far East and Southeast Asia, Southern Europe, and Northern Europe. Something interesting to note is that there is a very high concentration of highly connected ports in specific world regions, and in particular Far East Asia and Europe. The same picture also shows the country's Liner Shipping Connectivity Index. Countries that have different colors, and the darker greens are country is shown, the most that country is connected. You can see there is again a big difference among world regions. The Far East, Western Europe, and the USA are highly connected, whilst developing countries are not so well connected. This indicated that developed countries are facilitated in international trade participation, whilst developing countries are facing more challenges and in particular the inland nations. The table on your left shows how well connected is Korea with its top 10 partners. Korea is best connected by sea with China, with a score of 0.969. For this figure, the maximum is 1, followed by Singapore, Hong Kong, Malaysia, Japan, the Netherlands, Spain, Germany, UK, and Belgium. On the right, the figure shows the liner shipping connectivity index from year 2022 to 2020. The index has constantly been growing since 26, showing a constant improvement of the index over the years. This figure shows the liner shipping connectivity index for the top 5 Korean ports. On the top, in dark blue color, you can see that Busan is the most connected port by far. This is very important for Busan, as Busan is a major transshipment port in the Far East and needed to be very well connected to serve different markets and customers. This is a most detailed table showing the liner shipping connectivity index scores for the major Korean port in 4 quarters of year 2020. As we have already said, among Korean ports, Busan has the highest port liner shipping connectivity index for year 2020. The score from the first quarter to the fourth quarter of 2020 were 118, 116, 117, and 118. The second most connected port is Gwangyang, with a score of 60. So, as you see, there is a large gap between Busan port and other Korean ports. Also, at an international level, the port of Busan is ranking among the top connected ports. As mentioned before, Busan port, which recorded the largest throughput in Korea, handled about 20.9 million TEU as of the end of year 2020. In Korea, about 92% of containers to and from Busan port were transported by road, 6% by coastal transport, and only 2% by rail. In other words, most containers in Korea are transported by road. This means that as a peninsular country, container transportation using rail has no or little price competitiveness due to the relatively small land size. However, the current poor utilization of coastal transportation is considered to be a matter for improvement, as Korea is a country bordering 2 seas and relatively good port facilities. However, let's take a look at how the Netherlands and Germany have developed, the hinterland connectivity, and how the modal split is distributed. I'm introducing 2 ports in which hinterland modal split is well distributed. Rotterdam is a major container port located in Northern Europe. The cargo traffic composition is 65% for hinterland and 35% for transshipment. The hinterland modal split is distributed between road width is 54%, inland waterway transport which is 35%, and rail which is 11%. This is important as rail and the inland waterway combined represents the 46%, almost half of the container moving in and out of the port. The port is able to reduce congestion and the emissions thanks to the modal split distribution. Hamburg port is also one of the major container ports in Europe. I'm showing this case because it is similar to Rotterdam in terms of shares of modal transport to the hinterland. Road represents only 40%, rail 51%, and river barges 9%. So, more than half of containers moving in and out of Hamburg are moved by rail and barge. This is not common for ports worldwide, as containers are mostly moved by road. Before looking at the peculiarities of modal transportation related to the port's hinterland connectivity, let's take a look at the flow of container handling within a container port. The figure illustrates the unloading and the loading process at a typical container terminal. Unloading process can be divided into three different sub-processes. When a ship arrives at the port, container cranes or quick crane takes the import containers off the ship's hold or off the deck. Next, the containers are transferred from the container crane to vehicles that travel between the ship and the stack. After a certain period of containers are retrieved from the stack by crane and transported by vehicle to transportation modes like barges, deep sea ships, trucks, or trains. Both automated guided vehicle and straddle cranes move the container from quayside to container yard. The difference of two equipment is its use. Automated guided vehicle is commonly used in the automated ports such as Rotterdam, Qingdao, etc. The most common use of straddle carriers is in port terminals and intermodal yards, where they are used for stacking and moving ISO standard containers. During the containers transfer within the yard storage stacking cranes and floor track container stacking cranes are frequently used. All major container ports have rail track within the port areas and allow transfer containers to their final inland destination. An inland container depot or dry port refers to complex logistics terminal and an inland container base equipped with the scale and facilities for connecting two or more modes of transport. The main objectives of constructing an ICD is to reduce logistics cost by collecting and transporting a large amount of cargo at once. While the demand for transportation of cargo is rapidly increasing, the logistics facilities are insufficient, and this causes the increasing of companies' logistics cost and weakening the national competitiveness. It was necessary to build an interconnected transport network that transport large quantities of small and frequent cargoes of various types, so inland logistics bases such as ICDs were built at the nation's 5 major logistics hubs. Since the services of Uiwang ICD started on the outskirts of Seoul, the capital of Korea, in 1993, a total of 5 ICDs for each region have been built, and 2 are currently under construction. This is the last part of today's lecture, and I would like to introduce the smart port policy and development in Korea.
iTerminals 4.0 is an innovation project co-funded by the European Union through the Connecting Europe Facility Program that will implement Industry 4.0 concepts in the port container terminal industry. The project will facilitate the integration of technologies like Internet of Things, big data, artificial intelligence, and cloud computing to improve the efficiency, safety, and sustainability of container terminal operations. iTerminals 4.0 project is coordinated by the Fundación Valencia Port, and the project consortium includes the most relevant equipment manufacturers and software providers, as well as terminal operators all over Europe, proposing new Industry 4.0 solutions, which will be tested at strategic container terminals in ports of the TEN-T network. iTerminals 4.0 is addressing one of the main concerns in the port sector: the absence of harmonized operational and information exchange standards applied by the industry. This is a barrier that causes operational bottlenecks and emission impacts, thus reducing the overall efficiency of these facilities. In response to this, recognized port container operators, equipment manufacturers, and software providers have joined forces, creating the Terminal Industry Committee 4.0. iTerminals 4.0 is an action supported by TIC 4.0 to test and evaluate advanced Industry 4.0 pilots in port container terminals. That will include the upgrade of equipment sensor networks, the design of advanced big data and predictive analytics, the application of artificial intelligence, as well as the provision of business intelligence models and real-time dynamic KPIs reporting. iTerminals 4.0 will test Industry 4.0 technologies in 4 business areas for better decision-making to increase operational efficiency. Container handling operations are the core business for container terminals, and they integrate different interfaces and processes, which are usually fragmented and not well interconnected. The Container Terminal 4.0 will improve existing sensor networks to allow full connectivity and real-time information exchange among different container handling equipment, making possible real-time data analytics. Port operations in container terminals combine human-to-machine interactions that are particularly dangerous considering the dimension, weights, and speeds of the loads moved. iTerminals 4.0 will develop new adaptive safety concepts to enable flexibility and advanced human-machine interaction by combining technologies able to create virtual safety geofences around port equipment, thus avoiding risks and dangerous situations. With more than 250 container terminals in Europe, it is estimated a yearly generation of 1.5 million of CO2 equivalent tons derived from container handling operations. iTerminals 4.0 will enable the measurement in real time of fuel consumption at port container terminals, so that providing dynamic environmental KPIs that will help the port industry to better control and reduce greenhouse gas emissions. Finally, port equipment maintenance represents a field where digitization can provide significant benefits for improving preventative and predictive maintenance, thus reducing costs and extending the operational lifetime of port equipment. Thanks to Internet of Things technologies, alarms of failure events will be directly transmitted to the maintenance departments to create repair orders automatically and improve maintenance processes, saving time and increasing port equipment reliability and lifetime. Thanks to the innovative Industry 4.0 solutions and pilot demonstrations, iTerminals 4.0 will enable real-time machine-to-machine communications, detecting operational bottlenecks, and designing real-time KPIs, thus reducing operational costs and environmental impacts, as well as increasing safety at ports. iTerminals 4.0, application of Industry 4.0 technologies towards digital port container terminals.
Before starting the last part of today's lecture, Korea's smart port policy and development, you watched a short video on the concept of smart ports. The main theme of this KOICA training is smart port. All of you who are taking this lecture are also working in the Port Authority. So I think you have heard a lot about the smart port already. There are various definitions of smart port. Port Technology International defines the smart port as a port that uses automation and innovative technologies including artificial intelligence, big data, Internet of Things, and blockchains to improve its performance. UNCTAD mentioned a smart port needs to equip the workforces with relevant skills and technology to solve the unique internal and external challenges of the organization and to facilitate the efficient movement of goods, delivery of services, and smooth flow of information. The Port of Rotterdam, the main hub port in Western Europe, is known as a leader in transforming a large part of the port into a smart port. The CEO of the Rotterdam port emphasized smart ports focused on three roadmaps: smart logistics, smart energies, and future-proof port infrastructure. Deloitte, a well-known global consulting firm, pointed out the smart ports are the only ports that will survive. In Korea, smart port policies have been jointly implemented by the Ministry of Oceans and Fisheries, related ministries such as Strategy and Finance, Construction and Transportation, Science and Technology, and the Port Authority. As you all well know, the port used to be a space for simple loading and unloading in the early days. But today, it has become a core space that creates added value based on automation. The first generation port is a loading and unloading port, and it lasted until the 1960s to mid-1970s. The second generation port is an industrial port, which until 1980s that became the driving force of Korea's industrial development. The third generation port is a logistics supply chain port, which post 1980s. Lastly, the smart port construction phase started from the end of 2010, centering on container ports. Container terminals in Korea are operated in the form of semi-automated terminals, except for one Busan Container Terminals in Busan, Newport, which opened in February this year. It has been reported that in the case of a global fully automated terminal, the number of port calls increased by an average of 21.8%. But the berthing time increased only by 4.59%. On the other hand, the number of berths vessels calls in a completely automated terminal decreased by 3.05%, but the berthing time increased to 16.23%. For automation and digitalization will be promoted in earnest by year 2030. To this end, we plan to build a port automation test bed in Gwangyang Port by year 2026 to develop the localized technology and gain operational experience after verifying the test bed. Localized automation technologies will be introduced to Jinhae New Port, Busan, or second Busan New Port, and the Korean Smart Port will be operated in earnest from 2030. At the same time, consultations with the union will continue to minimize the job losses due to the introduction of automation technology and to convert them to high-quality jobs. In addition, by establishing a platform that can share information between users, such as shipping companies and terminal operators, and linking it with autonomously operated ships and autonomous trucks, the intelligent port logistics system will be completed. The Korean government expects 10 benefits from the introduction of a smart port. Port efficiency will increase because automatic identification and dictation of containers in the smart port will help ports increase handling capacity. Artificial intelligence and automation can mean a safe working environment. Accidents will become less common with automation. AI can analyze data to create a more risk-free environment, and having this information in real time can result in a safe working environment. More cargo can be created in less time with a reduction in load times, and eventually it will boost port productivity. Smart port helps make intelligent choice. Monitoring and data collection will help make better overall decisions. A virtual version of the port, dubbed the digital twin, can use real-time information to improve decision-making and problem-solving and support predictive planning. Artificial intelligence help with security checks and other automated processes. Technologies that can control port access for security reasons. AI has the potential to track maintenance on ships and predict when parts may break down. Smart technologies are transmitting real-time data about operating conditions. That enables the port to proactively identify the needed maintenance or requires and thereby avoid unplanned downtime. 5G technologies enables the fast and high bandwidth communication. It offers better energy efficiency and will be more reliable than old types of signals. With the introduction of appointment system, just-in-time arrivals are enabled. Just-in-time arrivals is a concept in which a ship maintains the optimal operating speed to arrive at the port only when the availability is ensured. It is estimated that ships spend up to 9% of their time wasting at anchorage. This wasting could potentially be converted to reduce speed and result in less greenhouse gas emission. A smart port will coordinate vehicle movement to improve traffic flow between ports and the cargo destinations. Lastly, the shipping industry is responding with strategies to go green as IMO year 2020 is fast approaching. Shippers have some strategies prepared to become compliant. This slide you see now is a fully automated terminal that will be completed Busan New Port Phase 2-5 and 2-6 in year 2026. Total annual container throughput of the terminal will be approximately 3.4 million TEU. The slide you see now is a smart port development plan for Incheon Port. Incheon Port, which has the second largest volume of cargo in Korea, plans to build a fully automated port in phase 1-2 of the Incheon New Port with the goals of opening in 2030s. This is the end of the presentation. We looked at administrative, organizational, and the connectivity issues in ports from the Korean perspective. I hope this presentation will give you some benchmark points to be considered in your country's port development. Please do not hesitate to contact me at hsnap@kmou.ac.kr if you have any questions regarding this presentation. I hope you will enjoy the rest of the KOICA program, and I wish to express my hope that those of you here and the people of Sri Lanka are healthy, well, and are overcoming this dreadful pandemic. And I hope that Sri Lanka will return to its vibrant pre-pandemic life as soon as possible. One more thing I would like to mention is that the Korea Maritime and Ocean University, where I'm working at the moment, has good relationships with various organizations such as the Sri Lanka Maritime University and the Navy and the Port Authority while carrying out the KOICA project. I hope you will have good memories of Korea and my university. Thank you very much.
The place where you pioneer the future seas and take on challenges while dreaming of making the world your stage. That plays the role of leading the new maritime era for maritime powers. a maritime university that is a strategic base. This is Korea Maritime and Ocean University. The Republic of Korea has infinite possibilities to grow as a maritime country. The driver that lead Korea to become a great maritime power for more than 70 years. At the center was the Korea Maritime and Ocean University.
한국해양대학교는 부산 그리고 한국에만 머물지 않습니다. 바다가 있는 곳이라면 세계 어디든 우리의 무대가 될 수 있죠. 더 큰 세계에서 활약하는 꿈, 이곳에서는 현실이 됩니다.
Korea Maritime and Ocean University is the chair university and secretariat for the Asia Maritime and Fisheries Universities Forum and is performing its role as a maritime leader. The result of multilaterally penetrating overseas and expanding international exchanges has resulted in the conclusion of exchange agreements with 122 well-known universities in 37 countries. Through the Global Training Project in the Maritime and Port Field, Campus Asia Aims and other projects, the university is involved in exchanges with other maritime countries and is roaming a broader maritime spectrum. The Korea Maritime and Ocean University will revamp itself as a global maritime hub.
바다의 자원이 무궁무진하다는 걸 누구나 잘 알고 있습니다. 하지만 아무나 도전할 수는 없습니다. 바다에 대해 잘 아는 전문가를 양성하는 곳이라 저는 한국해양대학교를 선택했습니다. 그리고 제 선택이 옳았다는 걸 다시 한번 확신하게 되었습니다.
The Korea Maritime and Ocean University has various maritime specialized and advanced facilities and equipment to cultivate experts in the maritime field, including the Hanbadaho ship and Hannadaho ship for providing hands-on learning for advanced marine technicians. Skilled maritime personnel are cultivated through the Marine Simulation Center that enables simulation training related to ships. Also, there is the VR room that can show ultra-large offshore plant structures in 3D video. The Industry and Academic ETRS Center, where various new technologies and advanced teaching methods are employed and other top facilities are used to conduct maritime education and research. Moreover, students can freely take part in discussions and learning in a cafe-type learning area. Thanks to the effort and training of maritime personnel, the Korea Maritime and Ocean University leading maritime education, research, policy, and culture in the Republic of Korea, and the university developing into a maritime specialized, comprehensive university recognized the world over.
신해양 시대를 선도하는 길라잡이 대학으로 해양 분야 핵심 브레인 양성을 위해 다양하고 전폭적인 지원을 하고 있습니다. 든든한 동문, 아낌없는 지원, 체계적인 학사과정, 모든 것이 준비되어 있는 해양 특성화의 메카, 여기는 한국해양대학교입니다.
Beyond the sea, the Korea Maritime and Ocean University encompasses a bigger world. The school manages specialized education and research for all fields, including the traditional maritime fields of ocean transport, shipbuilding, ports, and distribution, but also the fields of ocean engineering, ocean science, marine finance, and ocean leisure. Further, in step with the Fourth Industrial Revolution, the school is leading the future maritime industry with autonomous navigation, smart ships, and maritime future cities. The school takes the lead in cultivating maritime experts that think in an integrated way through specialized learning that integrates diverse study and links and converges them with the maritime field, such as humanities, society, science, and physical education. The place where there are leaders cultured in a global way. The place where there are personnel responsible for the future maritime industry. The comprehensive university with a global maritime specialization of the highest international standards. This is the Korea Maritime and Ocean University. Methodical maritime personnel are cultivated at 3 colleges: the College of Maritime Sciences, the College of Ocean Science and Engineering, and the College of Humanities and Social Sciences, and at 5 graduate schools: the Graduate School of General Studies, the Ocean Science and Technology School, the Graduate School of Maritime Industries, the Graduate School of Maritime Finance, the Graduate School of Global Logistics. The first maritime educational institution in Korea, the Korea Maritime and Ocean University, was restructured as a comprehensive university in 1992 and was positioned to be the cradle of learning that puts into practice integrated convergence education. The Korea Maritime and Ocean University has been unwavering for more than 70 years of leading Korea's maritime industry. At the center were 60,000 alumni. The alumni that are playing core roles around the world in the maritime field form a stable community.
오늘날 우리나라가 세계 10위권의 경제 대국이 되기까지 바다는 세계로 나아가는 커다란 무대였고 여기에 한국해양대학교가 그 여정을 든든히 함께 해왔습니다. 제가 한국해양대학교에서 익힌 지식과 이를 기반으로 한 여러 경험들은 우리나라의 해양, 해운 항만 물류, 그리고 수산 분야 정부 정책을 맡고 있는 해양수산부 장관의 업무를 수행하는 데 큰 힘이 되고 있습니다.
한국해양대학은 저와 세계를 이어준 징검다리였습니다. 해양은 세계 무역과 지구촌 동반 성장의 무대이며 대한민국은 세계 해양 경제를 계속 이끌어 나갈 것입니다. 한국해양대학은 이러한 기대에 부응하는 글로벌 인재를 양성하는 세계적인 대학입니다. 앞으로도 지속가능한 세계 해양 경제와 한국해양대학의 무궁한 발전을 기원합니다.
학창 시절 기억에 남는 일은 매일 아침 뛰었던 방파제와 한바다의 실습 항해입니다. 그때는 훈련이 정말 많아서인지 모든 일에 자신감이 있었습니다. 지금껏 해양 경찰로 근무하면서 바다에서 다양한 사건, 사고들을 많이 접했는데 학창 시절 배운 자신감으로 잘 헤쳐나온 것 같아서 늘 목에 대한 자부심과 감사하는 마음으로 근무하고 있습니다. 한국해대 사랑합니다.
그동안 저희 한국해양대학교가 배출한 약 7만 5천 명의 동문들이 여러 산업 분야에 진출해 있는데 특히 해운 및 해양산업 분야에는 국내외를 불문하고 각 영역에서 눈부신 활약을 하여 업계의 발전은 물론 국가 발전에도 크게 기여하고 있습니다. 한국해양대학교는 우수한 해운 및 해양산업 관련 인재를 배출하는 최고의 요람임을 자부합니다.
우리 대학은 우수한 교수님의 교육을 바탕으로 직원들도 최상의 행정 서비스를 제공하기 위해 노력하고 있습니다. 학생이 재학 중 필요로 하는 다양한 요구들을 수용하여 학생 여러분의 미래 꿈을 이룰 수 있도록 지원을 아끼지 않을 것입니다. 세계 최고 수준의 글로벌 해양 특성화 종합대학에 걸맞은 행정 서비스를 제공하기 위해 앞으로 더 노력하겠습니다.
Having been selected by the Ministry of Education for a core project, the Korea Maritime and Ocean University is receiving solid support and will provide a high standard of education to students so that they can lead the future of Korea's maritime industry. The Korea Maritime and Ocean University is active in exchanges with excellent universities overseas and is developing global ocean leaders. Here, our global personnel dream big.
한국해양대학교는 최고의 해양 인재를 양성하여 우리나라가 해양 강국이 되는데 큰 역할을 하였습니다. 그러나 이에 그치지 않고 다양한 학문과 연계하여 융합적 사고를 갖춘 세계 최고의 글로벌 오션 리더를 양성하는 데 앞장서겠습니다. 한국해양대학교와 함께 하시기 바랍니다.
A vast sea. We are not afraid to venture out beyond Korea into the world. The Korea Maritime and Ocean University will be the compass and our dependable companion on the voyage of our life.